Hello everyone, and welcome to another video with Special Maths Academy. In this video, I'll be looking at the 16th problem from the Special Maths Contest of 2023, the first round. But before we go into the problem, please don't forget to like, share, comment, and subscribe. Now let's go into the problem. Three sequences a(n), bn, and cn satisfy a(n) equals a(n) plus 1 times a(n) minus 1, and b sub n plus 1 is equals to bn plus 1 times bn minus 1, and cn equals to a(n) plus 1 times bn minus 1 for all integers n. Find the least value for t greater than 0 such that we must have cn plus t equals to cn for all n. Okay, so arbitrary sequences want to find the period of sequence c. Okay, so let's look at sequence AN. And my guess is that this has to be a periodic sequence, but let's investigate that. That's why this is math. We have to be sure of what we are saying. So AN, we have AN is equals to AN plus 1 times AN minus 1. So let's see if we can form some ratio. So here we have AN over AN minus 1 is equals to AN plus 1. Okay, so we have, replace n with n plus 1, we'll have AN plus 1 over AN equals to AN plus 2. Replace replace n with n plus 1 again. So just generating subsequent then. So I have AN plus 2 over AN plus 1 equals to AN plus 3. Okay, so let's observe. Okay, so we have this, we have this, and we have this. Okay, so let's look at this sequence here. This, we can see that 1 over AN is equals to AN plus 2 divided by AN plus 1. Okay, and that is equal to this. Okay, so basically we have this is equals to AN plus 3. Okay, so we have AN plus 3 is equals to 1 over AN. Okay, so that's when we move by 3. So this means AN plus 6 is equals to 1 over AN plus 3. Okay, and this is equals to what? AN. Okay, so it means we must have AN plus 6 equals to AN. Okay, so let's erase this and just put it somewhere. Can we pause the video? No, take it back to see what I wrote. Okay, so we have AN plus 6 equals to AN. Okay, that's nice. So let's look at the sequence Bn, see if we can get anything interesting. Okay. So we have Bn plus 1 is equal to Bn plus 1 times Bn minus 1. Okay. So let's see what we can get from here. As you can see, this plus 1, creates an issue, sort of an issue, and we want to take the ratio. But let's see if we can get something nice from there. I mean, we could still take the ratio. We could still take the ratio and see where that leaves us. So, okay. So we can see that Bn plus 1 is equal to Bn plus 1 divided by Bn minus 1. Okay. So I have Bn plus 2 equals to Bn plus 1 plus 1 divided by Bn. Okay. You can see Bn plus 3 is equal to Bn plus 2 plus 1 divided by Bn plus 1. Okay, what can we observe here? Can we observe anything interesting here? Let's see. Okay, so let's try and see if we can, find some sort of bridge. So let's replace Bn plus 2 here. Okay, so this is going to be Bn plus 1 divided by Bn, then plus 1 divided by Bn plus 1. Okay, let me scroll down a bit. So we have Bn plus 3 equals to Bn plus 1 plus 1 plus Bn, okay, divided by Bn plus 1. Okay, so this is equals to Bn plus 1 plus, okay, so let me scroll down. Okay, so this is equal to, let's just express it like this. Okay, next let's try to get Bn plus 4. Okay, so Bn plus 4. Bn plus 4, that is going to be equal to Bn plus 3 plus 1 divided by Bn plus 2. Okay, so how can we break this down? Okay, so let's break it down. Let's try and express it in terms of Bn plus 1 and Bn. So our Bn plus 4, this is equal to, so Bn plus 3 is this. So just put Bn plus 1 plus Bn plus 1 all over Bn plus 1 plus 1. And then Bn plus 2 is Bn plus 1 plus 1 all over Bn. Okay, so here we have Bn plus 4 equals to Bn plus 1 plus Bn plus 1 plus Bn plus 1. Okay. Okay, so let's multiply by Bn as well. So this will be Bn, Bn squared. No, let me do this again. So this will be Bn into Bn plus 1 plus Bn plus 1 plus Bn plus 1 all over Bn plus 1 to Bn plus 1 plus 1. Okay, so this is going to be equal to, let's see, can we simplify anything from here? Okay, I think, I think we should try to see what we can simplify here. Okay, so quickly, you can see that I made a mistake here. So um, from here, okay, so we should get, so I'm going to write in a different color. When we multiply the numerator and denominator by bn, we should get this, so times bn. Okay, so this is supposed to be times bn. So we're supposed to have this. Then, so that's doing well with this. And yeah, so we should have this. And okay, so let's see how we can now simplify this. Let's just check that the mistake is corrected. Okay, yeah. So let's see how we can simplify this. Okay, so everything looks like it should be in order. Now we can see that this expression here can be factorized. So this is equals to bn plus 1 into bn plus 1 plus 1 divided by bn plus 1 into bn plus 1 plus 1. Okay, so this can cancel out. So I'm left with, so let me increase the thickness of my marker. So I'm left with bn plus 4 equals to bn plus 1 divided by bn plus 1. Okay. And where have we seen this before? So let's scroll up. So I'll just write it here again. So this is what we have. Okay. So where have we seen this before? Okay, so let's look at what bn minus 1 is. So from this expression here, so bn minus 1. So from here, these two, they swap places. Bn minus 1 is equal to bn plus 1 divided by bn plus 1. Okay, so we have bn plus 4 is equals to bn minus 1. Okay, and because if we do plus 1 shift, so we have bn plus 5 is equal to bn. Okay, so we can see that the period for sequence B is 5 and the period for sequence A is 6. Okay, so now we have Cn, okay, is equals to this times this. So Cn equals to An plus 1, Bn minus 1. Okay, so since Cn is formed from the product of these two sequences, of course, okay, if we look at, so let's look at Cn. There's some these things, you can always pause and look at what I wrote. So we look at Cn minus 1. This is equals to An times Bn minus 2. And then if you look at, so we're looking from the perspective of the period of An, we look at Cn plus, so we had 6, so this would be plus 5 is equal to An plus 5, Bn, so plus 3. Okay, so this Cn plus 5 here is equals to, remember, An plus, rather, this should be plus 6. Okay, and this should be plus 4. So Cn plus 5, remember An plus 6 is equals to An. So Cn plus 5 is just An, Bn plus 4, okay? Now if you keep on doing this, and then if you consider like, okay, so let's look at it. So basically it's going to be the LCM, but let's look at Cn, okay? And let's look at Cn plus 30. This is equals to AN plus 31, BN, BN plus 29. Okay. So remember that the periodicity of AN is 6. So this is going to be equal to, so this is going to be equals to AN plus 1. Okay. So our working mode 6, and here this is going to be equals to, so remember our working mode 5, BN minus 1. 29 is minus 1 mode 5. That's how we get that CN plus 30 is equals to CN. So it has to be the LCM of the two sequences, the LCM of the periods of the two sequences, and that is option E, 30. I hope you enjoyed the problem. I hope you learned something new. Don't forget to like, share, comment, and subscribe, and see you in the next video. Goodbye.